In this video, we're going to go over simplifying these expressions. Okay, so for the first one, A, what we want to remember here is our exponent rules. So specifically, we want to remember the quotient rule that if we have x to the y divided by x to the z, we can write this as x to the y minus z. Okay, and so I'm going to go term by term to solve this. So I'm first going to look at what a squared divided by a to the third is going to give me. So I can apply this rule. So I get a to the 2 minus 3 is a to the negative 1. So I know this term is going to look like 1 over a, right? In my final, like when I bring all the terms back together. Okay, now my b terms I can take care of. So I have b over b to the 5th. And we'll want to remember here that when there's no exponent, there's kind of an invisible 1. Okay, and then I can apply my rule. So b to the 1 minus 5 equals b to the negative 4. Okay, and so then I can do my negative exponent rule to put this in the denominator because we never want to have our final answers with negative exponents. All right, and then my c term, there's only one c. There's no c in the denominator or anything, so that will just stay. But then my 4/12s I want to figure out. So 4/12 is going to be, I have 2 times 2 here, and then 2 times 2 times 3 here. So I can cross out the 2's and get 1/3. Okay. So let's put this all together. So I have my 4 over 12 became 1/3. Okay. My a squared over a to the third became 1 over a. My b over b to the 5th became 1 over b to the 4th. And then my c term just stayed as c, right? Okay, so then I'm gonna have my c in the numerator, and in the denominator, combining those terms gives me 3ab to the 4th. Okay, so you can always just go term by term like this, since they're, all these terms are being multiplied in the numerator and multiplied in the denominator. We can figure it out term by term and then just multiply our answer at the end. Multiply our answers, okay? So this is what we get. All right, so part B. So whenever I see something like this, where it's like an x squared minus something x plus a constant, I'm gonna think, okay, I probably want to factor. All right, or else this is gonna be really tricky to divide, okay? So x minus 4x plus 4, let's think about that. So x squared minus 4x plus 4. How could we maybe factor this? Well, we know for this, our constant term, we can have 1 and 4 or 2 and 2. And x squared is just going to be 1 and 1. So we know that we'll just have 1x and 1x. And then we have a negative 4x. And so we know there has to be a negative somewhere, right? In order for us to get into the negatives. But since we have a plus 4, we know that our constant term has to either be, 2 positives to get us the positive 4, or 2 negatives multiplied by each other to get us the positive 4. And since we already have 1 negative, we know, okay, the other one has to be negative as well. Okay, so then we can just try terms. So, if we had 1 and 4, well, that would be negative x minus 4x, which does not equal negative 4x. So it's going to be our other option, right? So x minus 2, that gives us minus 2x minus 2x equals negative 4x. And then this can be written as x minus 2 squared, because they're the same factor. All right, so then let's look at our x squared plus 3x minus 10. Okay, so for 10, we could have like 5 and 2 or 10 and 1. And then our x is just 1 and 1, so we have x, x. All right, so my middle term's positive. My constant term is negative, so I'm gonna have one of these factors have a negative term, right? Because if I had two negatives, I would get a positive. But if I have two positives, I'll also get a positive. So I have to have a negative multiplied by a positive to get negative 10. All right, so we can just try terms again. So let's see if we have like 10 and 1. Yeah, this 10 and 1 are not going to give us 3x, right? Because this would be negative 10x plus x. It's not going to work. We want terms that are closer together to get us 3x, right? So do x minus 5, x plus 2. Let's see, that would give us negative 5x plus 2x. So that's incorrect. So we'll switch them. And this would give us negative 2x plus 5x, which does equal 3x. So that's correct. All right, so now we can rewrite our fraction. So we know the top part is going to be x minus 2, x minus 2. Okay. We can like expand it to make it easier to look at for now. And then we will have x minus 2 here and x plus 5, right? Okay, so there's an x minus 2 in both the numerator and denominator, so I can take those out and just write this as x minus 2 over x plus 5. Okay, and then that is my final answer. All right, so for C, okay, so for this one, what I would think about is taking out a common factor, right? So 15 and 3, I notice both have a common factor of 3. So, when I do 15 divided by 3, I get 5. And if I did, 3x divided by 3, I would get x. So I can take out that factor of 3 and write 3 times 5. That would give me my 15, and then minus x, right? Because that would give me my minus 3x. Okay, so we think for the denominator, they both have 2x, right? Because 2x squared divided by 2x equals x, and 10x divided by 2x equals 5. Okay, so I can take out that 2x and have x here, so that gives me my 2x squared, and then minus 5. That would give me my negative 10x. Okay, so these two factors aren't the same, but I can notice that they're kind of similar, right? They both have a 5 and an f and an x and then a negative. So what I can do is take out a negative from one of the factors to make it equal the other one, right? So let's take 5 minus x. If I take out a negative, so right now I have 3 times 5 minus x. If I instead decide to do negative 3, so I'm kind of taking out a negative, this would change to negative 5 plus x. So do we see how that would still give us our negative 3 times negative 5 would be 15, and our negative 3 times x would be minus 3x, right? So we still get the same thing. We just kind of transfer the negative from inside this parentheses to the outside. Okay, and then this can be rewritten as x minus 5. So now we have negative 3x minus 5 over 2x, x minus 5, and now we can cross that out and get negative 3 over 2x. All right. Okay, the last problem. So I do have some pretty large x terms here. Okay, but I noticed that every term I'm given has an x, so I'm probably going to want to try to bring out an x, right? So let's see. Um, I also can notice that every term, like let's look at our numerator first. Every term is divisible by 3 as well, right? Because 3 and 3 are divisible by 3, and 18 divided by 3 equals 6. So I can take out a 3x. So 3x times x squared. And then I would do minus x to get my second term, right? Because it would be 3x times x would give me that 3x squared. And then for the 18x, 18x divided by 3x is going to be 6. Okay. Then let's look at the denominator. So here I'll notice that our common factor is 6x squared, right? Because they 6x to the third, we have the 6 in there, and then x to the third power, and then 18x squared. 18 is 6 times 3, and then we have x squared. 6x squared here, and then x minus 3. Okay, so to simplify more, I'm gonna want to factor what I have by this 3x, right? So x squared minus x minus 6, how can I simplify that more? Well, let's think. So our factors here are going to be 1 and 1, right? When we're just thinking of setting up our factors here, it's just going to be x times x. And then for 6, you could do 1 and 6 or 3 and 2. Okay, so let's see. And I'm going to want one positive and one negative because I know I need a negative to get to a negative like x term. And then I have a negative 6, so I can't have two negatives because that would give me a positive number, right? Because two negatives multiplied by each other gives you a positive. Okay, so I could do, say I did like 1 like this. Well, that give me 6x minus x. That's not negative x. Let's try 2 and 3. Be 2x minus 3x. That equals negative x, so I know that's the correct factorization. So I can rewrite this as 3x, x plus 2, x minus 3 over my 6x squared, x minus 3. And so now I notice that I can cancel these terms out. So I have 3x, x plus 2 over 6x squared. And now 3 divided by 6 is going to be 1/2. Okay, so I can write this as x plus 2 over 2x squared. Here, I'll just write that 2x squared. And so now the final thing I can do is I have an x in the numerator and an x squared in the denominator. Basically, this looks like this, right? So I can cross out an x in the numerator and denominator and be left with x plus 2 over 2x. Okay, then that is your final answer.